Hello, students. We are taking a look at the homework 7.1b. You'll notice you've got 1 through 7, 10 to 11, 13 to 16, and number 19. Now, some of this, again, might feel very natural because you have good experience with it. It totally depends. A lot of times students prefer decimals over fractions. Um, of course, they may not see the fact that decimals are fractions. Hopefully you have seen that now after watching that first video. So taking a look, let's kind of work through some of these. So write each as the sum in expanded place value form. So I gave an example of that earlier. For example, 2.35 would be 2 times 10 to the 0 plus 3 times 10 to the minus 1 plus 5 times 10 to the minus 2. You could also, if you prefer writing your negative exponents as fractions, you could do that too. 2 times 10 to the 0 plus 3 times 1/10 plus 5 times 100. That would be perfectly acceptable too. Okay. All right, so anyway, that's the idea. Sum, I rewrite it as a sum in expanded place value. Make sure your place values are here, and we are in place base value 10. Rewrite each of these as a following. So again, going forwards and backwards, 1 and 2, right? Take this, write it as a decimal. Take this, write it as expanded, okay? Write each of the following as a decimal. So again, 3 and 4 match up pretty nicely. Write 1 as a decimal, write 1 in words, so get used to it. So again, this, if we had to write this in words, we would write 2 and, because our and is the decimal point, and 35 what's 2 decimal places? That's over 100. 35 hundredths, and make sure the THS is on there. If you say 3,500, what you've really wrote down is 2 plus 3,500, which is not the same. It's very, very different, okay? And let's see here. Next up, write this as a terminating decimal as a over b. So rewrite it as a fraction. And it does say in simplest form. So make sure you do put this in simplest form. As an example, if we had 2, 3, 5, I could rewrite this as 2 decimal places. So it's over 100. Now I could put the 2 in front, leaving it as a mixed number. I could put the 2 on top, leaving it completely as a improper fraction, but it does say simplest form, and I notice there's a 5 here, so I could divide each of these by 5. So now it's going to be 20ths. Let's see here. 200 divided by 5 is 40. Was that 47? Let's see here. 5 and 4, 200. Yep, 47 20ths. Okay, so that is what they're asking me to do here. The only other pieces in 20 are 2 times 2 times 5. None of those go into 47, so I know this is simplest form. Okay. Next up, what do we have? Mentally determine whether they represent terminating decimals. Got it. Remember, terminating decimals have to have a denominator, with simplest form having only 2's and 5's as factors. Okay. And then what whole numbers? Did I say, what did I say? 1 through 7. Oh, well, I saved you on time, but it's only temporary, because if you take math 106, we will definitely be doing a lot with time as it relates to analog clocks, those fractional pieces, fraction of a minute. We get to kind of make angles with the hands on the clock and determine exactly what time those happen. So that's kind of fun. Let's see, then 10 through 11. Okay, so put these in order. So remember, negative numbers and positive, make sure you're kind of lining them up. Not a bad idea to think of kind of moving from left to right in place value notation, because the largest value you see, in the case of like A, they're all 2 in the tens place. That's great. Next value, they're all 4 in the ones place. So far, they all match up. And then just move down the line until you find where there is a difference. Whenever you first find that difference, the larger value, the larger digit in that place value is going to make for the larger number. Okay. That is different though if you have, that's true for positive numbers. It's the opposite for negative numbers. Again, the larger value in a place value means you are more in debt, or further down to the left in the negative value. Okay. Let's see here. Write words into decimals. Got it. And okay, so that's 10 to 11. Let's see, 13 through 16. So if the decimals are arranged in a typical number line, which is farthest to the right, again, putting things in order, write a decimal that's between these two. Oh, interesting. Okay, remember that idea that we could kind of put additional zeros on to values to the right-hand side and not change the overall value of the fraction or decimal. Argue that there are infinitely many terminating decimals between two specific values like this. How would you know there's infinitely many? Maybe there's not. Maybe there's only 10,000 of them. How do we know there's more than that? And then which of these represents 0.6? And we'll move over to number 19. Number 19, write the decimal number that the arrow points to. Now notice here, this is 3.00 or 3 and 0 hundredths. This is 3 and 100th. And if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there are 10 little tick marks intentionally. So that's how we can do it. I'll make a separate video for the MCs for this one. Hopefully you found that helpful. Again, for the most part, these short terminating decimals, not that bad. Not that bad at all. All right, off you go.